So hello everyone. Today we will be doing CB31 sheet 1008 problems. So let's right jump right into it. Um, so our first problem is traffic lights. You found yourself on a red walk across the circle red, yellow, and green. Okay, red, yellow, and green. It is known that the traffic light repeats its color every n seconds. Okay, so basically we are given three colors: red, yellow, and green. Right. And what it says that traffic light repeats color every n second, and at ith second the color SI is on. It repeats after like n seconds, and at ith second SI color is on. Okay. So basically it repeats its pattern like this: red, green, green, red, yellow, red, green. Basically string repeats itself. Oh, okay. It's formal definition. It's you need to cross the road, and that can only be done when the green color is on. Okay. So we are allowed to cross only when green is set to 1 or something like that. Okay. You know, um, you know which color is on the traffic light at the moment, but you don't know the current moment of the time. You know which color is on traffic light at the moment, but you don't know the current moment of the time. You need to find the minimum amount of time in which you are guaranteed to cross the road. You can assume you cross the road immediately, for example, with current color R, right? So current color R, what it says, like I need to reread this paragraph properly. You know which color is on the traffic, which color is on the traffic light at the moment, but you don't know the current moment of time. You need to find the minimum amount of time in which you are guaranteed to cross the road. You need to cross the road, and that can only be done when the green color is on. Basically, it's saying that we know which color is on at the traffic light at the moment, but we don't know the current moment of time. Okay. You need to find the minimum amount of time in which you are guaranteed to. For example, with S equal to R, G, G, R, Y, and the current color R, there are two options. Either the green color will be on after 1 second or after 3 seconds. Hmm. Right? So we can basically it's saying that we can only cross road and the color is green, and we know the color on the traffic light, but we don't know the current moment of time, so we need to find the minimum amount of time in which we are guaranteed to cross the road. Minimum amount of time in which sounds it's like it feels like a hmm. Let's try to analyze this example properly. For example, with S equal to R, G, G, R, Y, and the current color R, there are two options. Either the green color will be on after 1 second or after 3 seconds. Why after 3 seconds? That way the answer is equal to 3. That is the number of seconds that we are ready to cross the road if the current color is R. Okay, basically like okay, so like let's try to analyze this. R V G R Y, and basically the string will repeat, right? R V G R Y, right? Like this, and it will continue to repeat. So it's saying we don't know where we are here anywhere, right? So we can be like we just know that current color is R. We can either be here. This is why let's write it properly. We can only cross at we can only cross at green color, right? Hmm. We can either be here, either be here. Or there are two options either though. Okay. You know which color is on the traffic light, but you don't know the current moment of time. You need to find the minimum of time which you are guaranteed to cross the road. Minimum of the time that we need to cross the road. So basically, we need to find the worst case scenario, right? In which it will take the largest amount of time to reach. So basically, yeah, if we are currently here, suppose, then we need to go to all this. Then we will be able to cross the road. So basically, we will require 2 seconds, right? I guess this is how it is going on with from my approach. Just like I'm not sure if we find a better method, we will try to improvise on that. But currently, I'm thinking of going in this direction. Let's try with different test cases. Let's suppose this one YRRGY. So we are given 5 by YRRGY, right? YRRGY. We know that we are currently like basically if we try to make the string repeat itself, it will look like this, like this. So basically, it's saying that he can either be here, either be here, either be here, right? And we need to find the maximum distance between y and g, which is of course this one, this to this, right? So basically, this distance one, 1, 2, 3, 4, which is 4, right? 1, 2, 3, 4. Yeah. Let's analyze another test case. For example, this one, RG, 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 right? What was the test case? 7R. 7R, RG, RGY, RG, RGY, RG, RG, RGY, RG, and like this, it will repeat itself. We are currently at R. See, we observe all the R. It will require only 1 second to reach the green, right? Just we need to finish this one and we'll reach the green. So basically, we have to find the worst case to ensure like that we will must reach to the green, right? So I'm thinking in this direction and I think I am correct. Okay. So let's try to code this up. Right. Mm. So basically, first we are given the size string, and then we are given the character, which is like indication, or I can say current, right? Then we are given our thing, and let's take the input, right? So basically, we have to at least double the string to check it, right? Because like in this case, we had to check this. Hmm. So yeah, we basically have to check that. So let's double it. S plus equal to S and N. Okay. Hmm. Now what we have to do is basically we have to find the maximum distance between the our color and green, right? Say we go from here, iterating through like this. This is our color. We'll store it. We'll try to find the next green. Control, right. This is not a good way, like, I'm feeling like, I think we should iterate back because green is our important indication to find the Y. Like for this green, these two Ys are in competition. And for this green, this Y is in competition, right? Similarly, for this green, this red is in competition. And for this green, this red is in competition. Okay. Okay, it makes sense. Let's iterate from back. And I equals to n minus 1. I less than, I get it equal to 0, I minus 1 minus. Let's keep a variable char, or should I like, I need to track the position of temp, right? Green pos is equals to fill. I can store it to minus 1, it doesn't matter. Right, and we have to maximize the distance. So we can send it to interval. I think length, it is getting at the sum of n for all test cases does not exceed 2 for 5. N can be like, if we are like we can, we are doubling, okay, it can exceed. We should use, I will use L everywhere. Okay. Okay. So if as dot I is equals to green was equals to I, right? And if as dot I is equals to correct, right? If it's equal to current character, what we will do is, like suppose it's here, we'll try to update the distance between them. Suppose it's 0, 1, 2, 3. So we will directly store like this. Alex is equals to max. Oh, and green is not equal to minus 1. Right? We have to check that. Mx comma. Distance between green was, I think upper root will be better. Green smallness. There's no time. Right? So basically for here it will update it to 3. It, like we will iterate from here. It will give the value of, okay, we have to have iteration from here. Okay, no problem. We have doubled it already. I think I should take long here also. Hmm. Okay. try to see what is answer you're getting wrong. It's just too much. What I did. Hmm. What am I doing? What am I doing wrong? Hmm. Oh my god. Yeah, it seems like this code is correct. Let's try to submit. Yeah, we got an AC gear. This problem. Good. It was a good problem. Good observation. Hmm. Let's try another problem.